welcome to another episode of SCFG Live, Science Club for Girls Live. I'm Hannah with Science Club for Girls, and that was Mr. Music with your theme song. Walking in a winter wonderland. Oh, I get it, because it's snowing outside, which is crazy because it's spring here in Boston, and it shouldn't be snowing. Nice one, Mr. Music. Thanks for that. Well, it's actually perfect that it's snowing today, because today we're talking about phase changes, which is very relevant. But I couldn't really do this without our good friend and science sidekick, Nemisha. So let's bring her in and see what she's up to.
Hi, Hannah. And hello, all of you scientists. And you're totally right, Hannah. It's really yucky and snowy and icy out, but that's perfect for our episode today. I'm super excited for today's episode too, because I'm really looking forward to doing some ice painting today.
Me too. I can't wait to combine art and chemistry again. And I also want to give a special shout out to people who are watching today. I see Gianna and Christina. Can't wait for you to join in with today's experiment. But first, before we jump in, let's go ahead and do a review of what we talked about last week. Last week, we had a fun and busy chemistry experiment with our good friends Azita and young scientist Anya from EMD Serono. We got sodium bicarbonate and baking soda, we got sodium bicarbonate, which was the baking soda, citric acid, like lemon juice or vinegar, to combine to make a bubbly explosion.
Yeah, and that explosion was the result of a chemical reaction. I remember that term from last week. And that chemical reaction was between the sodium bicarbonate and citric acid. The two chemicals reacted together and created something really brand new: carbon dioxide, water, and salt. The carbon dioxide is what gave us those bubbles in our explosion.
I don't know about you, Nemisha, but I think chemical reactions are a ton of fun.
Yeah, I totally agree. I could do experiments with them all day.
But for today, we're actually going to talk about something a little bit different. Today, we're going to learn about heat. Heat is a type of energy. It's something that we see all the time, like when you heat food up in a microwave or when you take a hot shower.
Wait, Hannah, we can even make heat right now by rubbing our hands together really, really, really fast. Do you feel it?
Ooh, yeah, I can feel my hands starting to get pretty warm from all the friction that we're creating.
Yeah. I sometimes do this in the winter to warm up my hands when I'm feeling really cold. That would be something we should do right now outside.
I agree. Very cool. Well, what exactly happens when we heat something up? We've talked about some examples of heat, but what exactly is going on?
Well, Hannah, when we heat something up, we're making it warmer. So like when we rubbed our hands together to make our hands, we felt that it was warming up and it provided us with some heat. And when we do that, we're doing something to the molecules in our hands. Remember, everything is made of molecules, which are those really tiny, small particles that are put together. Yep, those right there.
Oh, I totally remember that. And I actually remember it from our episode about density. So what exactly is happening to the molecules when we add this heat?
Well, heat actually changes how the molecules move. Let's look at an example. Here is a glass of water, all the molecules of a glass of water. We can adjust the temperature of the water using this sliding cool scale over here. So Hannah, what do you notice about the water molecules as I start to move this scale towards hot and make the temperature warmer?
Let's see. Oh, wait, it totally looks like they're moving faster and kind of starting to get a little bit farther apart from each other. It's kind of like they're becoming more energized, like they're soccer players on a field. And when it was cold, they were kind of moving pretty slow. But now that you've heated up the water, they're starting to run really, really fast with lots and lots of energy.
That's an awesome observation and a great prediction. Adding heat gives those molecules extra energy, just like you said, and they're able to move faster. And then, depending on how much heat you add, you can also cause things to change their state of matter. Remember, we learned the states of matter a few weeks ago from our good friend Tamar. Remember, we learned that the 3 states of matter are solid, like this cup, liquid, like the water in the cup, and we have air, which is the gas like the air inside this bag. So when we change the state of matter that something is in, we call this a phase change.
Oh, I totally makes sense. And I totally remember that from the episode with Tamar. And it's pretty cool that heat can cause these phase changes. It's kind of like when you put cold butter on a piece of really hot toast. I noticed that the butter will start to kind of melt and become from a solid, it will change into a liquid. But how are these states of matter relate to how fast the molecules are moving?
Wow, that's a great question. Which state of matter is something is in, it depends on how far apart the molecules are and how fast or slow those molecules are moving. Okay, so let's pretend that my two hands represent two molecules. Awesome. So when the molecules are tightly together like this and they're barely moving, they're like really stuck together, it's a solid. If the molecules start spreading out a little though, and they kind of start to move, what do you think it is, Hannah?
Well, I know when a solid starts to melt, it turns into a liquid.
Great, exactly. And then if the molecules spread out even further and move really, really fast, they become a gas.
Oh, that's so cool. And it kind of makes sense. Like solids don't really move that much. They kind of stay the same shape. So it makes sense that their molecules are kind of not moving and pretty close together. But liquids, I know, are a little bit more swishy and can change shape. So it makes sense that their molecules move a little faster. And then the gas will move really fast. It's really cool how adding heat just causes these molecules to move faster and sometimes move so fast that these phase changes can happen. And that definitely explains why on a hot, hot day, my solid ice cream can change into a liquid ice cream soup. If you can think of any other examples of phase changes, definitely write them in the chat box.
Definitely. And that was a great connection, Hannah. And this also explains why water on a very hot stove can become gas. I don't know about you though, but I'm really ready to see some phase changes in action.
Me too. Well, there's no better way to show phase changes than doing ice painting. You ready?
So ready. I'm excited. So what are we going to need for this experiment?
Good question. So for this experiment, we are going to need a couple of different things. You're going to need to make some ice. Now, if you want to make ice in an ice tray, that's great. Or you can make ice using a plastic container. Just freeze some water in it and it will make a cool shape like this. If you already have ice cubes made at home, you can also use that too. Okay, so we have ice that's made. You also want to definitely have a tray or maybe a plastic plate to catch that water that's going to form. And then you'll need a paintbrush. You'll definitely need some paint. I'm going to use watercolors. And then you'll need some water. And that's pretty much it. It might get a little bit cold, so if you wanted to use gloves on your hands to keep them protected, you can do that too. All right, Namisha, do you have your ice frozen and ready to go?
I do. I have them in a little bit of a different shape. I'm going to try making a castle.
Ooh, that's kind of cool. I have a big piece of ice, and I think I might put these little pieces of ice on top of them to make kind of like a fort, maybe pretty similar to what you're doing.
Ooh.
All right. Now that we have our structure made, it's kind of the fun part. Now it's time to paint using our watercolors. I'm going to use maybe some purple, I think.
Ooh.
It's one of my favorite. What's your favorite color, Namisha?
I love blue.
Ooh.
So I think I'm going to use blue.
That's a good idea. Oh, look, my ice is starting to turn purple. I've never really painted with ice before. I always paint on paper, so this is kind of cool.
Me too.
Namisha, have you ever seen those huge like ice sculptures that sometimes people make?
I have. It's so cool how they make it until they even sometimes make them like statues, like they replicate a person. I think it's so cool.
Ooh, that's really cool. Also, shout out to the chat box right now. I see Christina gave us an example of a phase change, which is snow melting, which is kind of what Gianna said is happening outside right now. That's a great example of a phase change. And let's see, Clara Jane says, water is the only matter that can be solid, liquid, and gas. That's pretty cool.
Ooh, I wonder if we'll see that today. What color is you adding, Hannah?
What color am I doing? I'm still doing purple. I'm trying to do the whole base purple, and then I think I'm going to do some red maybe on the top.
Oh, I'm adding some pink in mine.
Oh, very nice. If you're doing this at home, definitely comment and tell us what you're painting for your ice sculpture.
Definitely. You're going to try to make a castle, or are you going to try to make maybe even a biome for all those polar bears?
Wow. Wait, Namisha, I'm already starting to notice something, actually. It's pretty warm in my apartment right now, so I'm noticing that some of my ice has kind of started to melt into water, creating these colorful puddles on the bottom of my plate.
Me too. And even when I started with these big castle blobs of ice, they were even bigger, but now they're like you said, mine are kind of turning into puddles of, well, liquid water.
Right. I wonder if this is basically a phase change that we're seeing right in the front of our eyes. Solid ice turning into this liquid water.
Yeah. Well, I feel like I have an idea for us to see a little bit of more of a phase change.
Okay, what's that?
Well, let your ice structures at home sit out for a little bit in room temperature. But for right now, let's speed up this process a little bit, and we're going to see what happens when we add heat to our structure. And I think that we can use a hair dryer for our heat source today, and we can blow on our ice structure.
Great idea. Because I know when I blow dry my hair, it definitely feels really hot. So there's definitely that hot air coming out of that hair dryer.
Definitely. Well, we have to make a prediction, though. So, Hannah, what do you predict will happen when we add our heat to our ice structure?
Well, I kind of already started to see it happening with my structure in that the solid ice was changing into this liquid water. And I remember from before we even started this experiment, you saying that sometimes adding heat will cause those molecules to speed up and cause this phase change to occur. So I'm definitely thinking we might see some melting and changing from solid to liquid. But let's see.
Good prediction. Let's see. All right. I have my ice structure and I have my hair dryer.
Ooh.
All right. 3, 2, 1.
Wow. Oh, I'm starting to see some puddles of purple forming.
Yeah, and if you look on the top, you can start to see that the ice is turning into like this liquidy. I feel like it's going to start melting even more as I leave it out.
Definitely. Super, super cool. If you notice any changes with your art at home, definitely take a picture and send it our way or write about it in the comment box. Super, super cool. All right, so we had some fun painting and we saw this phase change of solid ice turning into liquid water. But now I want to see an experiment where our liquid water turns into a gas. So Namisha, what are we going to need for this next experiment?
Okay, I'm super excited to see this phase change now. It's going to be different. So for this experiment, you're going to need a half cup of water. But why don't you fill it up to 1 cup, because we're going to have 2 cups and we're going to fill it both of those cups with half a cup of water.
Cool.
So get 1 cup of water total. Get your 2 cups, or you can use a container, anything that you can fill the water in. Perfect.
I have plastic glasses. That work?
That works. Those are some nice glasses, Hannah.
Fancy.
You're also going to need a marker, or you can even use tape.
Namisha, I'm actually going to use a dry erase marker because like we learned last time, the polymer in dry erase markers is not very sticky. So it wipes away pretty easy.
That's a smart idea. I like that. If you can use a dry erase marker, a permanent marker, or you can even use tape or even a sticker, just something to stick on your cups. You're also going to need some aluminum foil to cover one of the cups, or you can even use a lid. And then, if you want some food coloring.
Ooh. I got my blue.
Are you ready?
I'm ready. I have my blue. I actually already dyed my colors, my water blue. I got my blue water, 2 cups, aluminum foil, and marker. What do we do?
All right. So let's take our cups and let's fill those both with a half cup of water. All right. Cool. Now, you can do what Hannah did and dye your actual water so that you don't have to do this step. But if you do have food dye, let's add a couple of drops of those in each of our cups. I think food coloring is so cool.
Me too. It's so cool how it so easily dissolves into the water.
I know. Okay, so now let's take our marker or a dry erase marker.
Yep.
And let's mark where we have the top of our water.
Okay.
Just like that.
Did you just mark it once or did you mark it?
Yes.
Just once? Okay.
Yes. Just
cool.
On both of our cups though.
Okay, awesome.
All right. Cool. Okay. Now let's cover one of our cups with your lid or aluminum foil, whatever you have. So take any cup and just cover it.
Just one of the cups, right?
Yes, just one of the cups. All right. So now we're going to leave these 2 cups next to a window for a couple of days and try to put your cups near a window that gets a lot of sun in, because this is going to be our heat source, like that hair dryer in our last experiment. The sun is going to be the source of heat that's going to come down on our cups, just like we put the hair dryer on that ice. And then once you put the cups near the window, every day you're going to mark where the water level is on each cup with your marker, or your tape, or your sticker, whichever one you choose. And then you're going to compare the water levels on both of the cups after a couple days, okay, to see which one's higher.
Awesome. I think I might keep track of that in maybe like my science notebook. Make a little table.
Ooh, good idea. Tables are always fun. So because this experiment takes a few days, Hannah and I have done the experiment beforehand. But before we take a look at what the water levels look like in each cup, let's make a hypothesis. Which cup do you think will have a higher water level after several days? Write it in the chat. What's your hypothesis?
Well, I think because the 2 cups are sitting by the window and there's like a lot of sun, and you said that the sun in this experiment is our heat source, that must mean that the molecules in the water are going to be changing in some way. So they're going to be moving probably a little bit faster and faster. And eventually, I think they're going to get so fast that a phase change is going to occur. And I think the liquid water might turn into a gas.
Ooh, that makes a lot of sense to me. Kind of like how rain puddles disappear after the sun is out for a while when they're on the rain puddles. But remember, we covered one of our cups. Do you think that'll make a difference and we'll still see a phase change?
That's a good question. Well, I'm thinking with the cup without the lid, the water is definitely going to turn into a gas. And because there's no lid, the gas has a place to escape from. So, but actually, the other cup that does have a lid, when the water changes into a gas, it's going to get trapped. And I think it might turn back into water and fall back down. So I think we'll definitely see less water in the cup without a lid and probably the same amount of water in the cup with the lid.
That is a great hypothesis. And Gianna has a similar hypothesis to yours. She said she thinks that the one without the foil will have less since there isn't any cover. So that's awesome.
Great prediction, Gianna.
Definitely. Well, let's take a look at what happened.
I left mine out in the sun for about 4 days. Luckily, I did this before today because today was not very sunny.
Yes.
All right. Let's see. I'm going to take the, actually, no, I'll leave the lid on. Let me see if I can find my line where I marked it. Okay. So this mark, see if we can see it. This is where the water started. And this is where it is now. And this is the cup without the lid. So it looks like I did lose some water in the cup without the lid. But in the cup with the lid, it looks like I pretty much have the same amount of water, maybe a little bit less than I did when I started. So it looks like my prediction was correct. The cup with the lid had about the same amount of water, and the cup without the lid definitely lost water because the liquid turning into a gas and escaping from our cup.
Yeah, and the same thing happened to me, and I left it out for 1 day less. So that shows that the same thing is going to happen even if you just lay it out for 1 day.
Really cool. I definitely think you guys should try this at home and maybe try it in a different type of cup. I wonder if a cup that has like a bigger mouth on the top makes a difference Or if a cup with a smaller mouth on the top would have less water. I don't know. There's so many different things to try. Maybe leave a cup of ice out or something. I don't know. Lots of
Yeah, that's a really good idea. I wonder if you use a different food coloring dye, if that'll make a difference. Maybe the chemicals in the food coloring. I don't know.
Ooh, or maybe if you add some salt to the water, add sugar to the water. Oh my gosh, there's so many different experiments you could do with phase changes. Well, I don't know about you, Namisha, but I had a lot of fun today. And this was actually a perfect experiment for today's weather.
I know, I did too. And I especially liked the ice painting. That was super cool.
Yeah. And we also learned a lot about heat. We learned that heat is a type of energy, and adding heat causes those molecules to move faster.
Yeah, and we also learned that adding the heat can cause this phase change, where things change into different states of matter. Like when you add heat to solid ice, like we did, it turned into liquid water. And then when you add heat to liquid water, it turned into the gas.
Great point. I also see Christina's wondering where Dr. Marbles is, and Dr. Marbles actually had a previous engagement, unfortunately, but he'll be back for our next episode, which, speaking of which, our next episode will be in 2 weeks on April 30th. We are off next week. Definitely gives you time to experiment at home, but we'll be back April 30th with Dr. Marbles and Namisha and Mr. Music and the whole crew. Until then, it's been another great episode of SCFG. Bye, everyone.